All right, so we are going to go through each of the topics we've covered since the beginning of the school year and answer some questions about them. This is information that will be on a quiz. And again, it's just like the beginning of the information you need to know in order to do all of the units in algebra. Okay, so let's start off with number one. Okay, so for number one, specifically domain and range, here's what I'm going to say about these. I'm going to give you an answer, but don't worry about domain and range. I am not going to ask you about what's called a discrete function, right? This doesn't have any connecting lines, right? So I'm not going to ask you about this one, but this is just for your information. The domain of this one is just going to be a list of numbers. So we're going to use a little squiggly line. Let me do a better squiggly line there. Okay, so we're going to do a little squiggly line. It looks like something like this. Okay, and we're just going to list each of these x values. There's one above -4, -2, 2, 4, and 5. So I'm just going to list those numbers. Okay, -4, -3. I'm sorry, -4, and then there's one above -2. Above +2, above 4, and above 5. Okay, and then for the range, I'm going to do the same thing, but I'm going to look at the y-axis and say it looks like there's a point right here next to -2. So when I'm listing this one, it's -2, and then if I go up, I see the next one's next to 1. Okay, and I have a point next to 2. Okay, and I have a point next to 3, right? So I'm going to say for my y values, these are the only y values that have points next to them. This is what's called a discrete function, so like it's not connecting, so we're not getting everything between -4 and +5. We're only getting these specific points, okay? But again, I will not ask you a question on the test about this. We did not cover it in class this year, and so you will not be responsible for this on the test. But if you were curious, that's why, okay? You will be asked these other questions down here, because we did talk about function notation, okay? So remember we said for f of -4, the -4 is the input value, which we typically refer to as x, right? So if I'm thinking about a graph, an ordered pair is typically an x value and then a y value, right? So if I say f of -4, what I'm saying is that on this graph over here, there is a -4, comma something, and I'm asking you the question like, what is the output? What's y, right? So if I go over to -4, I can see that there's this point here which is -4, comma 3, right? And that means that the answer to their question, what is f of -4? The answer is it is 3. Okay, so I can do the same thing with this letter D, right? If I go over to 4, I go up, it looks like there's this point 4, comma 1, right? And so the answer to their question, f of 4 is equal to 1. Okay. For letter E, this one is actually doing the opposite. They're actually saying, when is f of x equal to -2? So another way that you might read this is, for what values of x will the output be -2? Okay, so it's going to be this same situation where there's an x and a y, okay? But instead of them giving us this first value, they're giving us the second value. They're saying the output is -2. Please tell me what input values, what x values will give me an output of -2, right? So if I go down to -2, I can see that there is only a point over here at this point 5, -2, right? And so I'm just going to say, okay, well, it looks like I had to use an x value of 5. So it looks like x is equal to 5 for this one, okay? And so that's all you have to do for problem number 1 is the input-output part, okay? All right, so for problem number 2, same basic idea, but there's a little bit more questioning going on here, right? And we should be able to do the domain and the range of this one. This one is what's called a continuous function, right? We did connect together all of the points. Okay, so I'm going to ask you in this problem to list the domain and range using both inequality notation and interval notation. And on the test, you might be asked for one or the other, so you do need to be able to do both. Okay, so let's start off with the domain. Let's just talk about it generally, and then we'll do the notation part, right? So it looks like for the domain, remember, domain is kind of like what values of x are being used to make this graph. And we have to remember that for the graph, that there's an arrow right here that's going to the right forever, right? It's right and down, right? And this one's going to the left and down forever, okay? So I can kind of say this one goes to the right and to the left forever, and it covers everything from -infinity all the way over here on the left to +infinity all the way over here on the right. So it's kind of covering everything, right? There's no end in either direction. So what I'm going to say in inequality notation, there's this symbol, right, that looks like this, and this means all real numbers. Okay, so I'm going to write it here for the first time. Okay, all real numbers, which means I'm kind of saying like include everything. So for my domain for the inequality notation, instead of using an inequality, I'm just going to write, hey, use everything. Okay, for interval notation, the way we write that is go from negative infinity, which is everything to the left as far as you want to go, to positive infinity, which is everything to the right as far as you want to go. In interval notation, we will use a round bracket for our infinities because we can't include those, right? So it's just like go as far to the right as you want, okay? For the range, we're going to do the same thing, but this one does have an endpoint. So I'm going to grab my highlighter real quick just so we can see it, right? This one goes up and it stops right here, which is at y value of 3, right? So when I'm writing my inequality, I'm going to actually say, as long as you are less than 3, right, all of the numbers below 3 are where the graph is. Anything that's above 3, there's no graph. So in inequality notation, I'm just going to write y is less than or equal to 3. Okay, and again, less than or equal to is important because this is a filled in dot, which means I am including 3. Okay, just as a side note, this graph labels the y-axis as g of x, so it's also correct in this case to write g of x is less than or equal to 3, right? So that's how they're referring to the y-axis, but if you write y is less than or equal to 3, that's fine, okay? In interval notation, we're going to use infinities to say, okay, my smallest value is the most negative one, so that's going to be negative infinity, okay? And I'm going to keep going up and up and up until I get to 3, okay? Now here's the important part about interval notation. Again, just like up here, infinities never have round square brackets, okay, but because 3 is being included, this is a less than or equal to problem. I'm going to use a square bracket on the right hand side, okay? So this would be my interval notation for the range, okay? Just like in problem number 1, we can find out specific points, right? -2 is my input, and I can go up to 3 and see that 3 is my output. Okay, and then the same thing with the next one. If -3 was my input, I can see that 1 is my output. Okay. And then they're asking me, when is g of x equal to -1? Here's where you have to be really careful, right? I can actually, if I go down, I'm going to use my same purple line here, okay? And I'm going to just move it down, okay? So that we can see -1. Here's -1, right? When the y value is -1. And I can actually see that there are 2 locations where x is hitting -1, right? I need to include both of those, right? So the answer to this one is, if x is equal to 0, right, I have the point 0 comma -1, and when x is equal to -4, right, because I have -4 comma -1, right? So there are 2 answers to this question. In order for you to answer it completely, you do need to include both, right? Because it's just saying, when is it equal to -1? Well, both of these spots are correct, okay? All right, so for the last 2 questions down here, the last few questions down here, they're talking about intervals, okay? So intervals of increase, remember, are like uphill, right? And intervals of increase are downhill. So we're essentially breaking up our domain, right, which is everything, into different parts that describe when's it uphill, when's it downhill, okay? So that would essentially be this point right here, this -2 comma 3 is where the graph stops going uphill and starts going downhill. This is the turning point, right? So when I'm stating my intervals, I'm going to say, you know what, go as far to the left as you want, start at -infinity, and as you travel to the right, the moment you hit -2, okay, this is not increasing anymore, it's going to turn around and start decreasing. So I'm going to say the interval of increase is going to be from -infinity up to -2, okay? I'm not putting a square bracket here specifically because the point -2 is not at a part of the increasing interval. This is actually where it turns. It's not increasing or decreasing here, right? So it's not a part of this interval, so I'm using a rounded bracket, okay? So that would mean the interval of decrease is going to be everything from -2 as far to the right as you want to go, which is what we call positive infinity, okay? So we're going to say this one is going to start at -2, okay, and it's going to travel to infinity. Okay, so notice again, -2 is the smaller number, so I started with that on the right. Okay, the last thing we need to talk about for this problem is the end behavior, right? So I have these 2 arrows down here that are both pointing down. Okay, so just to remind you about this, okay, what we're going to do is we're going to write 2 statements. One is going to be about the left-hand arrow, and the way that I'm going to indicate that I'm talking about the left-hand arrow is write x approaches -infinity. This means if you go to the left on the x-axis, right, if you go to -infinity, you're traveling to the left, right? If I write a different statement and say x approaches positive infinity, this is my way of talking about the right-hand arrow, because I'm saying as x goes towards the positive numbers, okay? So if I'm going to say, as x approaches -infinity, what's happening? Well, if I go up to my graph, this left-hand arrow is pointing down, right? So what I'm going to say is, g of x, because that's what we called the graph. Again, if you put a y here, no big deal, okay? That's going to go to negative infinity. Okay, negative infinity is me kind of saying like the thing's pointing down, right? That's negative infinity, right? And then I'm going to say the same thing for this right-hand side. The right-hand arrow is going down, so on that side, g of x is also heading towards negative infinity, right? So this is how I would write the end behavior of this graph using notation, not words, okay? So I don't just want to write up, up, or down, down. I do have to describe it using the notation, okay? So problem number 3, same basic idea, so we're going to go through this one a little bit more quickly. Okay, so the domain on this one does start right here. If I kind of draw this line at the end point, right, it looks like it goes to the left at -4, so as far as -4. So I'm going to say x is greater than or equal to -4. Again, notice just one endpoint, right? So I'm not using two inequalities, okay? In interval notation, I'm going to say you're allowed to start at -4. You're going to go as far as to the right as you want, so I'm going to use infinity. Round bracket for the infinity, but I am including -4, so square bracket on that side, okay? For the range, this thing does go up forever, right? So even though this endpoint makes it stop on the left, it does continue on the right forever. So for my range, I'm going to say as long as you go above -4, right, when y is greater than or equal to -4, you're going to find graph. If you go below -4, the graph never goes that low, okay? So in interval notation, I'm going to say start at -4, okay? Include -4, and go as far up as you want, okay? And then for the rest of it, again, g of -2, if I go down to -4, that's where I'm finding the graph. If I go over to -3, it looks like I'm going down to -3, and I'm finding a graph. Okay, notice how, like, this one had a point, this one doesn't, but it still does go through that point. Okay, I just didn't put the dot there. Okay, so intervals of increase. Okay, this one is increasing right here, right? It starts at this point where x is -1 and it travels as far to the right as you want. So I'm going to say starting at -1 and traveling towards infinity forever, right? If I'm talking about my interval of decrease, that's only going to be this little section here between -4 and -2. So I'm going to say the decrease is from -4 to -2. Okay. Again, smaller number on the left, okay? And then the last one is, again, end behavior. This one only has one arrow, right? The left-hand one does not keep going forever. So the only thing I need to do is describe this right-hand arrow, and that's going to be x approaching positive infinity, right? So I'm going to come down here and say that the right-hand arrow, which is when x approaches positive numbers, right? Then we're going to say, I think this one's called h of x at the top. Again, if you write y, that's fine. This one's going up, so that means that the y values are approaching the positive infinity side of things. There is not going to be another statement here, and that is because there is not a left-hand endpoint that I need to write about. Okay, so that's all you need to do for these graph analysis problems is be able to describe each of these things. Okay, all right, so moving on. Stating the domain and the range. Okay, again, if I don't specify, you're allowed to use either notation, so I'll kind of mix it up a little bit. Okay, this first one goes as far to the left and as far to the right as you want, right? These arrows are going to the left and to the right, right? So I'm going to use inequality notation for this one. So I'll say that for the domain, this one is everything, all real numbers. Okay, for the range, okay, it only goes down to this point right here, which is at -1, and it only goes as high as this point, it looks like, right? We'd say, oh, hey, look, it stops here. But we have to be careful. Oh, let me get rid of that. Hey, we have to be careful. This arrow goes up forever, right? So just because the right-hand side is flat does not mean that we're not covering things above that 4 line, right? This one, I'm going to get rid of this because it's actually not correct, right? This one goes up forever, but it does only go down to -1. So the way I'm going to describe this one is when the y values are greater than or equal to -1, but you can go up as far as you want to go, okay? To determine whether this relation is a function, right, remember the whole idea is every input's allowed to only have one output, and because this one passes the vertical line test, we're going to say, yes, this is a function, okay? For problem number 5, okay, we're going to do the same thing. We're going to say this goes, here's kind of my very left-hand point, but there are arrows making it go to the right forever. So this thing looks like the domain. Okay, I'm going to use the interval notation this time. The domain is going to be as far to the left as -3, okay, and as far to the right as you want to go. So infinity, round brackets always next to infinity. Okay, this does go down and up very slightly, but it is going up slightly and down slightly forever. So that would mean that my range is actually going to be everything. And the way we do write all real numbers, this symbol using the other notation is negative infinity up to infinity. Okay. So this problem covers everything on the range, but there is a restriction on the domain. Okay, for function, is it a function? In this case, we're going to say no. Okay, and the reason that we're going to say no is we can say it fails the vertical line test because it hits the graph twice, or you can describe this as I just found an input x is equal to 2, right, or x is equal to 1, where it hits it has more than one output, right? The definition of a function is every input is only allowed to have one output. Here's a case where I can show you an input value of 1 that has an output above it and an output below it, right? So that would be no. Okay. All right, we'll zoom through the rest of these because we've done all the explaining. Okay, so problem number 3, this goes to the left forever. I do see an arrow and an arrow. So we're assuming that this kind of wavy pattern continues forever, right? So I'm going to say that the domain is all real numbers, okay? The range, however, if we assume that this is continuing with this wavy pattern, goes as high as 2 and as low as -2. So the way I'm going to write this is -2 is less than or equal to y, which is less than or equal to 2. Okay, this one is a function because there's no spot that I'm going to be able to draw a vertical line and hit the graph twice. Okay, don't worry about problem number 7. This is a discrete function which we did not discuss. You are not responsible to do a problem like that. Okay, all right, so again, domain and range, just make sure you can look at a graph and determine the domain and range, and make sure that you can write it in both notations, inequality and interval. Okay. All right, problem number 8. Okay, so you're given 3 functions up here, f of x, g of x, and h of x. Okay, and they're just asking you to use function notation to answer some questions. This is very similar to what we did with the graphs, except now we're being given the equation of the graph instead of the graph itself, right? So if I say what is f of 2, okay, I'm just going to say that means input 2, 4 times 2 minus 10. Okay, so that would mean f of 2 is 8 minus 10, and that's -2, right? So that's the answer to letter A. Okay, letter B is the same thing, except we're going to h, right? So I'm going to say h of -1 is equal to 3 times -1 squared minus 5 times -1, okay? And here's where we have to be careful, okay? So if I do order of operations, I need to do -1 squared, make that look more like a -1. -1 squared first, which is 1. 1 times 3 would be 3. And then I'm separately going to do -5 times -1, which is +5. Okay, so h of -1 looks like it's going to be 3 plus 5, which is 8. Okay, so g of -2, same basic idea. I'm going to go to the g function, okay, which is this one right here. I'm going to plug in -2. Okay, and it's going to say 2 times -2 squared minus 7. Okay, so again, order of operations says -2 squared, which is 4. 4 times 2, which is 8. Okay, minus 7. So it looks like g of -2 is going to be equal to 1. Let's see if I can squeeze this in here, right? And then the last one, h of -3. Hopefully you've gotten the idea with this one. Okay, so I'm going to go one more time up to h, and I'm going to say h of -3 is equal to, I don't know if I'll be able to fit this one, 3 times -3 squared minus 5 times -3. Okay, so again, let's be careful with our order of operations. -3 squared is +9. 9 times 3 is 27. Okay, and then if I multiply together -5 times -3, I get +15. So h of -3, it looks like, is 27 plus 15, right? That looks like 42 to me, right? So h of -3 is 42. Okay, for letters E and F, hey, you're going to do the opposite. Okay, this one says for what values of x is f of x equal to 2? So what that means is we're going to go up to f of x. I don't know what this is. It's literally saying what values of x. So I don't know what x is. But what I do know is that I want this to spit out a 2. So I'm going to set this entire left-hand side. I'm going to replace f of x with a 2. I'm allowed to do that. They're the same. Okay, so I'm going to say 2 equals 4x minus 10. Okay, and I have to solve this now. Okay, so I'm going to add the 10 to the other side. That's going to make a 12. Okay, I'm going to divide by 4 on both sides, and what I find out is that if x is equal to 3, that will make the output of this f function 2. Okay, so that's what they're getting at here. Okay, for problem letter F, same basic idea. I'm going to go up to the g function, and I'm going to plug in a 1. Right, so this one's going to look like 1 equals 2x squared minus 7. Okay, and then we're going to just solve this one. We're going to solve letter F exactly like we solved letter E, except once the x squared is alone, we have to get rid of the squared using square root. Everything else will be the same, though. I'm going to add the 7 over, so that's going to be 8 on the left-hand side. Okay. I'm going to divide, just like I did here, right? I had 4x, I divided both sides by 4. Well, I have 2 something, so I'm going to divide both sides by 2, and now it's going to say 4 is equal to x squared. Okay, and then the only difference between these is this one's not done because it says, this one says x, problem over. This one does not say x, so I'm going to square. So I'm going to square root both sides. Okay, and so here's where you have to be careful. This is the most common mistake probably that I'm going to get on this quiz. If you square root x squared, you get x. If you square root 4, and if I'm asking the question, what did you square to get 4, there's 2 answers. There's 2, which I think most people will get, and there's also negative 2, okay? So you can write this either as x equals 2 and x equals negative 2. You might also write this as plus or minus 2, right? That would be the same thing, okay? So 2 answers here for what values of x is g of x equal to 1. Either of these numbers will work, and you have to include both. If you forget one of them, you're missing half of the answer. So be careful with that, okay? All right, almost done. I think we got this one and then some factoring. Okay, so completing the table is literally just plugging in the values. So if I plug in negative 2 squared is 4 times 2, which is 8, plus 3, which is 11. Okay, negative 1, if I square it, is 1 times 2, which is 2, plus 3, that's 5. Okay, if I plug in a 3 and I square it, I get 9 times 2 is 18, plus 3, 21. This last one, I'm not going to plug in 5 because that's not an x value, it's an r of x value. This one I'm going to have to maybe come off to the side and do a little work. So I'm going to plug in the 5 for r of x, and it's going to say 2x squared plus 3. I want to figure out what x value I should use to get it to output 5. So if I subtract the 3 over, I'm going to get 2, okay? And again, before I square root, let's divide away this 2. It's going to say x squared is equal to 1, and then I'm going to use my square root. So very similar to the equation version. X is equal to, and again, because I square rooted 1, it's going to be plus or minus 1. And if you notice, we already have one of these, right? Negative 1 spits out a 5. Well, the other answer is positive 1 splits out a 5, right? So if you write this as plus or minus 1, we've kind of redundant because we already have the minus 1. So you could either just do the positive version or both. It's either or, okay? All right. Last problems. We have to do some factoring, okay? So in each of these problems, your goal is going to be start off with GCF, okay? Once you found the GCF, you're then going to figure out which factoring method is the most appropriate, right? Whether it's AC factoring, difference of two squares, right? The grouping method, whichever one of those is appropriate for the number of terms in this problem, that's the one you're going to use, okay? So let's start off with number 1. So the first thing I'm noticing about this one is this has got all 10s in it, right? 10 times 1, 10 times 6, and 10 times 72. So let's take out that 10, okay? So it's now going to say x squared minus 6x minus 72. Okay, so our goal now is to figure out what numbers multiply to negative 72 that add up to negative 6. Right, so you may need to pull out your calculator here, and that's okay. All right, I'm going to pull out my calculator, which I don't believe you can see. You can't see that. Okay, so I'm going to just do some quick math and do 72, and then maybe divide it by like 12. Right, I know 9 times 8 works, but that's not going to give me a 6 in the middle. So if I do 72 divided by 12, let's see what happens there. That is a 6, right? So it looks like 12 and 6 work, right? So I'm going to split this one up. This is what I call the simple method. If I say x minus 12 and x plus 6, right, that multiplies to 72, the negative 72, and it adds up to the negative 6, so that's good. And then I'm not going to forget to bring down this 10. If you don't include the 10 in your final answer, you are missing a factor that you need to get this starting equation back, okay? Okay, so for problem number 11, same basic idea, right? We're going to look at this and say, what's the GCF, right? So if I'm looking at this one, I see that there is an x squared, right, for all of these, okay? I can check to see if there's a 6, but if you do check these, the 69 does not divide nicely with 6. So 3 is the biggest thing I can take out of this one. So I'm going to take out 3x squared. Okay? And then I'm going to write what's left, which is 2x squared minus 23x plus 45. Okay? And so if I look at this leftover problem, it does look slightly different than the one that I have next to it. This one has got a 1x squared. This one has a 2x squared. I have to use a different method because that 2 is there, right? And I couldn't get rid of it. Like this one, I was able to take the 10 out and get rid of it. This one, I can't. Okay, so I'm going to say in this case, let's use the AC factoring method. All right, so our A is 2 and our C is 45. So I'm going to say that 2 times 45 is 90. Okay, my B value in the middle here is negative 23. Okay, so if I look for numbers that multiply to 90 that add for negative 23, you might have to do a little guess and check on your calculator till you find the right values. In this case, we're going to say negative 18, okay, and negative 5 work. Right? If you multiply these together, you'll get positive 90. If you add them together, you'll get negative 23. Okay, so I'm going to say if I rewrite this expression, 2x squared, I'm going to, instead of writing negative 23, write minus 18x minus 5x, right, and then plus 45 at the end. Right, so I just changed the negative 23 into 2 terms instead of just 1. Right, I like uncombined the terms. Okay, from here on out, I'm going to use what we know about the grouping method, which is anytime there's 4 terms, I'm going to group the first 2. All right, it looks like I can take out a 2x, and that leaves behind x minus 9. Okay. From the second group, I'm going to take out a 5, but I'm also going to take out a negative with the 5 because I'm noticing that the signs are different and I want them to be the same. Right? I need this leftover to be exactly the same. Right? And so if I didn't take out the negative, this would have said negative x plus 9. Right? So I'm taking that out to be sure that that's taken care of. Okay. So I'm going to say 2x minus 5. Okay. Those are the outside parts. Okay, and x minus 9, that's the inside. Okay, and this is very easy to forget in a long problem like this. This 3x squared's got to come down and sit out in front. Okay, so that would be my final answer. Okay, this is now factored. Okay. Excuse me. So problem number 12. I see 2 terms. I do not see a GCF here, right? 4 and 25 don't have anything in common. X and Y don't have anything in common. So I have to just figure out a way to factor this from here, okay? And so the only thing you can do with 2 terms is a difference of 2 squares. And that's that whole setup where if I could write it as a squared minus b squared, then that allowed me to turn it into 2 parentheses, okay? And I take whatever I squared and place them in both parentheses, the a's in the front, the b's in the back, okay? And then in order to get a minus sign, I need a plus b and a minus b, right? So this is the rule that we follow for any 2-term polynomial, is write it as a difference of 2 squares. So I'm going to do that. Very fortunately, 4 is a perfect square. Okay? X cubed is a perfect square. I'm sorry, x to the 6th is a perfect square, right? Because I can say x to the 3rd times x to the 3rd makes x to the 6th, okay? So if you notice, whenever there's an even exponent, I can write that as a perfect square just by dividing it by 2, okay? So I'm going to do the same thing with the 25. I'm going to say 5y to the 5th, right, half of 10, okay, squared, okay? So I'm going to rewrite this one as, in this form here, 2 parentheses, okay? And I'm going to say 2x goes in the to the 3rd goes in the front of both of them. The 5y to the 5th goes in the back of both of them. Let's see if I can squeeze all this in here. Okay, 5y to the 5th. Okay, and then in order to get, again, the minus 25y to the 10th, I need 1 plus 5 and 1 minus, right? So this would be, as weird as it looks, the completely factored version. Okay, and then the last problem, again, I'm going to look at the problem and say, is there a GCF? That's always, always, always your first step. Okay, and I'm going to look at this and say they definitely all have 3's in them. And they all definitely have 1x, which I can't take out more than 1 because this last one's only got 1. Okay, so 3x. Okay, so what that's going to leave behind is x cubed. Okay, and then if I take away a 3x from here, that leaves plus 3x. Okay. And then minus 2x squared. And then my last one is going to be a minus 6. Okay. So I'm going to use the grouping method. I see 4 terms, right? This leftover can be we can try to factor it again. So I'm going to start off with this first group and say it looks like it's got just an x in common, right? I only see x here, right? So if I try to take that x out, I'm left with x squared, okay, and a plus 3. Okay, so I'm going to say that's what's left over. Okay, my second group, it looks like it has a 2 in common, but again, I see the minus signs, and this one's got positive terms. So I'm going to take out a minus 2. And hey, that also leaves behind x squared plus 3. Okay, not a coincidence. Just like up here, the x minus 9's matched. We should have a matching leftover. Okay, so it looks like factored this is x minus 2. Okay, those are the outside values. Okay, and then I have this x squared plus 3. And then I'm not going to forget that I had a 3x at the beginning, and that's got to come down as a part of my answer. So I'm going to put the 3x right there. Okay, so this is now completely factored using only the grouping method. Okay, so these 4 factoring problems represent each of the 4 methods you need to know, which is difference of 2 squares, AC factoring, what I call simple factoring, right, and then the grouping method. And any of these versions could have GCF. So that's the whole test. Okay, if you can do that, if you have any questions about this, please feel free to let me know.